Howdy, Huskies. We're going to go and do our day 3 for Algebra 2 today. We're going to look at exponential growth models. We're going to use a couple of formulas today. So our first one is going to be the general growth model. So that's the one we have highlighted in here. So let's go ahead and take a look at these variables. So the first one is an A. That is going to be the amount that, we don't need to open up my email there, that you accrue. If we're talking about, or we could say the final amount, that might be the easier way, but we'll say accrued to start, or the final. Then we have your A, that's going to be our principal. So when we talk about investing, that's the month we're going to start with. We could also call it the initial or the start. And then we have an R for our rate. So for that rate, my friends, the idea is it has to be a decimal, and that's going to be a big thing because almost everything's going to give us a fraction to start, so we're going to have to convert that. And last is going to be T for time. So ladies and gentlemen, this is going to be our equation. Now sometimes we're going to have to use X for time, and we're going to do that when we have to plug it in our calculator, so let's go ahead and just put it up there to start. Alrighty, so I guess some words of advice when we start this is the first thing you should really do is you should go ahead and say, look at what the question is asking first. Because sometimes they're not asking for you to solve it. Sometimes it's just to set it up. So if we read this first one, it says, write an equation for exponential growth. Cool. So all I have to do is write it. And how do I know what this growth is going to be bigger than 1. So that's how we're going to go ahead and have the 1 plus. So the other thing is to look at all your numbers. You might not need all those numbers in the case of what we're going to be looking at today, but at least we have them. So now we're ready to go. So it says, Mr. Mortara has a super awesome fish tank in his home full of guppies. Over the last 7 years, the initial population was 38 and has grown by 7%. So this 7 years sounds like we're going to use time. But ladies and gentlemen, boys and girls, what really we're going to do is we're going to say that that's how we got my rate. So this is how we got the rate. So we're not going to use this time. And you got to kind of look at that. Anytime it really says over the last couple of years, that's generally not your time. Okay. But this, a 38, that's going to be my initial, how much I start with. And then this 7% is going to go ahead and become my rate. Now, as we mentioned, that's 7%. So if I go 7%, to make that a decimal, I'm going to take the current spot of the decimal and move it 2 spots to the left. And then fill any of those hoops with zeros. So this is really 0.07. That's the decimal that we want to think of it. Alrighty. So we want to go ahead and write our model. So let's go ahead and start it off with A is equal to P 1 plus R to the T. So we don't know what we're looking for yet, so I'm going to keep it as A. My initial, we said that was 38 guppies, so I'm going to put the 38 right there. And then it's 1 plus my rate of 0.07 to the T. So when I do my combining like terms, because we can go ahead and add those together since it's in the parentheses, I'm going to get 1.7 to the T. And again, we know that this is growth because that's bigger than 1. And so that's kind of important for us just looking at formulas in general. Cool? All right, so part 2 here, sports fans, we got our second question. I'm going to go ahead and erase so we can focus. So I'm going to read that last question first. It says, use the table so you find out when will you have 92. So this is really kind of like a when. You can see that right there. And whenever you're going to use a when, that implies that we're going to use the table function on our calculator. Or graph it, because this is going to be an approximation. We're going to find out how to do that when we do logs in a second. So basically the idea is I want 32, so that would be my final. That's my A. And I started with 38 guppies, and we still have the 1.07 to the T. So that's how it's going to look. But when we take this part right here and we plug it into the calculator, my friends, we're going to take this and plug it on in, except it's going to go 38 1.07 to the X. Okay, that's going to be because we're solving for X. And if we plug in the T, the calculator is not going to understand what it's going to use, or it's going to use a stored value. So we're going to use that X button. Okay, and so I'm basically going to look. So when the y equals 92 via my table. So if I get my calculator out, got my key press history here so we can see. I'm going to go to y equals, and then I'm going to go ahead and just do 38 parentheses 1.07, and then do my up arrow for my exponent. That was this one right here. To the x, that's this x right here. And then if I hit graph, we're not going to see anything. And that's because we're starting with 32 guppies. This little table here is 10 by 10. So, makes sense. So what we're going to do is hit second and then go to table, and we can see where we're at. And we're going to find out when I hit 32. So it's somewhere in this area right here, sports fans. So we're just going to say it's in between 13 to 14 years. You can see that right here. Again, we said when was the y, 92, and it's somewhere in that region. We'll find out exactly when we get to logarithms. Cool? Alrighty, so ladies and gents, now we're going to talk about money. We do this equation a lot, so I'm going to erase so we can focus in on just this equation. If you need to go back, you can. So most everything is going to be the same, but what we're going to talk about now is this n. This n is going to be the compound amount. And you can see that compound amount in two different spots. So it's an important part. So what we're going to be looking is for something like monthly. So since there's 12 months in a year, if I compounded it, that'd be 12 times a year. Monthly disappeared, so let me put that back up. So monthly, my n would be 12. We could have daily, in which case my n would be 365. Another one we see a lot is quarterly. Quarterly, 4 quarters in a year, that would be 4. Or we could see what's that called annually, and annually would be once. Cool? So you really want to look at those keywords to decide what your n is going to be. But everything else is pretty much the same. So we're going to say, so find the balance. So we're going to actually do the formula for 20 years, assuming that the interest is compounded quarterly. What about 45 and 75? So we actually have 3 problems here, but I'll show you how to do it on the calculator, where once you set it up, it's pretty easy. But the compounded quarterly right here tells us, hey, that's important. That means my n here is going to be 4. So that's important for our formula. So it says interest. We see our interest here is 4.3. So 4.3%. We're going to move our decimal 2 places, so that's going to be 0.043. My initial that I'm going to be investing, my principal, is $5,000. And so we're going to do this again. We have 3 different times. So I have a time for 20 years, 45 years, and 75 years. So let's first do 20. So 20 years would be 5,000 for my initial, 1 plus 0.043 divided by 12, because it's quarterly, so that's 4. And then the 4, because it's n times t, 4 times 20. So that's our equation. If you want to do this math right here like we did in the previous one, you could. But since that's going to be a pretty small decimal, I'm just going to put it directly on into the calculator. So I'm going to hit second quit to get out of that. And I'll clear this out so we can see. And so we're going to go ahead and do 5,000 parentheses 1 plus 0.043 divided by 4. Close my parentheses and then do the exponent. 4 times 20. Now, some of you are going to have to put parentheses around that big number up here for your exponent, that 80. But most calculators, we can just plug it in and hit enter. So I get 11,000. That's not 11,000. There we go. 761.69. So that's how much money. And notice that we have right here, it keeps on going, but banks aren't going to give you that extra cent until you earn it. So we have to round kind of down to the nearest cent. So what happens if we're going to do 50 years? 45 years. So 45 years. So the only thing that's going to change is this number right here. So if you have one of our cool TI calculators, what you can do is hit second. Sorry, let me clear this out so we can see this. So second, and then enter for entry, and I'll bring it back up, and then you just use your arrows to go back and change that to 45. And then we hit enter, and look, we get a number, and it was a lot easier. So that's 32264.54. Now, if you want to write the actual formula and do it again, you can. It's 5,000, 1 plus 0.043 divided by 4 to the 4 times 45. Again, you can do that, but we're going to get that number right there. Alrighty. Ladies and gents, why don't you try 75? Hit pause, give it a shot. Welcome back. Let's see how we did. So I'm going to go ahead and second, enter, head back over up top and hit 75 to see how much this changes. And we're going to have 1, 2, 3, 6, 2, 1, then 0.78. So, ladies and gentlemen, those are going to be our 3 values here for all of our different compounding amounts. So you can see that it starts slow and then it gets high pretty quickly towards the end. Now, my friends, when you invest, you should probably invest a little bit more than just one-time sum if you want to make a huge gain like in a 401k. But that's not the equation we're looking at today. Alrighty. So this next one, it says, how much does Nadal have after 25 years if he compounded monthly? And then what about 50 years? So there's my monthly again. So my N is going to be 12. Here I have $10,000 that we're going to invest. I don't know why that keeps changing. So P is going to be $10,000. And then we're going to go ahead and take a look at my rate. So 6.1%. We need to change that to a decimal. So 2 spots. So 0.061. That's the decimal we're going to use. All right. And then, of course, our time is going to be 25, then 50. So let's set up our equation. So P1 plus R over N to the NT. We want to know how much money we're going to make. So 10,000, 1 plus 0.061 over 12. So the 12 times our first one, which was 25 years. So again, you can do this math if you want to, and you can do this math if you want to. But since we're plugging in the calculator anyways, let's just do it. So I'm going to clear out everything so we can see how we're doing. So 10,000, then 1 plus 0.061 divided by 12, close our parentheses, and then 12 times 25. All right, we're going to take that number here. It's going to be 45,774.26. Alrighty, so it made a pretty good time, but that's putting it in the bank for 25 years and forgetting about it. You didn't even think about it for 1 second. All right, so what about 50? So I'm going to hit second entry again, go back up and hit 50 for 50. And so after 50 years, we're going to get 209,528.37. Again, all this is a calculator work, so embrace it, use it. It's going to be helpful. All right, so to bring us to finalists, or to bring us home today, we have our decay formula. And decay, remember when we were doing that by graphing, was in between 0 and 1. So that's why it's 1 minus in this case, but everything else is the same, okay? This is still the rate. Then we have our time still. I just want to make sure I was still recording. All right, and then we have our principal, or we'll say the start. Okay, So anytime it says decay, or if you see something like decreasing in value, again, that's when we would know we need to subtract. So we have a $1,200 television, and it's decreasing by 21%. So that's 0.21. And we're going to say after T years, because we're just writing the equation. Write the equation. That's all we're going to do. Write the equation. So we'll go ahead and do 1 minus 0.21 to the T. So I can do this math. So it's 1,200, 0.79 to the T. And we got to double check. Is that less than 1? Yes, it is. So it is decay. All right, how about 2 years? Well, that's question number 2. So I'm going to put a 2 in right there. So 1,200, 0.79 to the 2. So we'll get our calculator back out, clear away what we had, move this up so we can see 1,200, 0.79, which is the same thing as 0.079, exponent 2. So it is 748. $748.92. Alrighty, when will it be 300? So again, we see that when, so that's going to tell us table. So we're going to say, alrighty, I have 300, 1,200, 0.79 to the what? To the x, because that's what we're looking for. So we'll get our calculator back up. Now, because I want to graph it, I'm going to hit the y equals button. Clear out that I have something already there. So 1,200. Notice I'm not going to put the 300 in there. Parentheses 0.79. And then to the x. Hit second and then table. So we want to know when it's 300. So I'm going to find out when the y is 300. So it looks to be right around this area. So we're going to say 5 to 6 years because we took the y part. All right, sports fans, that's it for today. We'll see you on the next one.